Kia ora 12 MCA and 13 MCA students who are redoing AS and my Year 10s. This is a question from Theo and it's a really, really good one. We're given a sine curve and we've got a transformation of it where there are three things that have happened to it. So we have to describe the sequence of transformations that have been put together, and we have to talk about the order that they've been applied in. There are two ways to do this question, and the way that I'm going to do it first is to rewrite it by factorizing this thing here. Now, if you are in 13 MCA and you've done level 3 NCEA Trig, you'll know that this is just an example of y is equal to a sine b times x plus c plus d. This here is my vertical shift, and in this case, there's no vertical shift, so that's a plus 0. Right, this is my my vertical stretch, and in here are the two that we have to be careful with, which are my horizontal shift and then my horizontal stretch. So some of you watching are probably going, well, why does she care so much about doing it that way around? And I don't really. I just think it makes it more intuitive what's going on in here if we look at it like this. So if we think about our basic sine curve, it goes like this. Oh, that's a terrible sine curve, but you get the idea, right? So there's 0, there's 180 degrees, and there's 360 degrees. The period of that function is 360 degrees. The first 0 point, or which is what I call it, is at 0. So if I look at the function written in the second way here, in my rewrite way, what I can see straight away by writing it like this is that I am going to get, when x is equal to 60 degrees, this thing here is going to give me 0, right? And that means that that's what my horizontal shift is, because it's not 30 degrees, right? 30 degrees is not any kind of thing. 60 degrees is where I'm going to get back to 0 in here. And then again, at 420 minus 60, I'm going to get back to 360. So sine of 360 is 0. So the first thing I'm going to talk about in here is that there is a horizontal translation, right? And I'm going to give you that language now. So this is working with it in this form, right? So y is equal to 4 sine of all of that. The first thing we're going to look at is the horizontal translation, right? So factor 1, or translation 1, so it's a translation, and it's a translation of y equals sine x, and it's translated by this vector. So it's translated by the vector, the x component is 60 degrees, 0, and then we could say, in kind of more informal language, by 60 degrees in the positive direction on the x-axis. So that's the first thing. Now, what's going on with this half? Well, the half is the horizontal stretch. And what you can see here is that when we do that, the period of the function, instead of being 2 pi, is going to be 2 pi divided by 1/2, which is 4 pi. Or in this case, instead of the period of the function being 360 degrees, the period becomes 720 degrees. So this is a horizontal stretch. And that means, how do I write that? Well, it's a stretch. And it's a stretch of y equals sine of x minus 60 degrees in the x direction, or in the direction of the x-axis. And we have to give the scale factor by a scale factor of 2, right? No, not of by 1/2, because that, so when we say scale factor of 1/2, that suggests we're getting it more squished, right? But we're doing the opposite. So the scale factor is always going to be 1 over the thing. And then the last thing we've got is the easy one, which is, where's it gone? This 4 here. And the 4 means that the maximum value is now going to be, where's it gone? The 4 is going to take the highest value up to, instead of being at 1, the highest value is going to be all the way up here at 4. And down here, it's going to be down here at -4. I don't think we were asked to draw the graph. No, we weren't. That's good, because this is very, very bad graph drawing. Okay, so factor 3 is then a vertical stretch of y equals sine of a half x minus 60 degrees in the y direction by a scale factor of 4. Okay, and so if you're going in order, the order here is 1, 2, 3. Let's look at what we could do if we hadn't done that change around. Because if we haven't done that change around, we have to rewrite things a wee bit. If we just start off by saying y is equal to 4 sine 1/2 x minus 30 degrees, we can still get there, but what we have to do is we first have to look at what happened to the x. Right, so think about back in year 9 when you were building up function machines. You started with x, you times it by a half, and then you took away 30 degrees. And then you did blah, blah, blah. Right? So it's the same kind of idea. So what we have to talk about here first, if we're doing it this way, is first we have to do the horizontal stretch. So we're going to do it this time. So stretch of y equals sine x in the x direction with a scale factor of 2. And then what we have to do is to say that that already squeezed wider thing is getting shifted that way by 30 degrees, not by 60 degrees. So then it's a translation by the vector 30 degrees 0. And lastly, again, it's the vertical stretch thing, whatever words I had here. Okay, and so the order again is 1, 2, and 3. And if you look in the mark schedule, they took account of both of those two cases because they're both fine. And then part B, Theo, you didn't ask me to do part B, but I'm going to do it anyway. But before I do that, I'm just going to show you some nice graphs so you see them using GeoGebra. So here are the nicely done graphs for Theo. This first one, so the first one is showing the green function is y equals sine x, and then the blue function is y equals sine x minus 60 degrees. Now, GeoGebra put this into radians for me, so don't worry too much about that. That's 180 there. So you can see that this point here is at 60 degrees. Okay, next thing we did is that we took that shifted over graph, so the blue graph is still the same one, and then we did the horizontal stretch. And you can really see how stretchy it is here. So now this next one is sine of a half x minus 60, and then in the last one I did the vertical thing for you, but I changed my graph scale a wee bit. So you can see that here it's going up to 4 and down to -4. So that's the full thing with all 3 transformations in. Okay, and I could have done those same 3 graphs for doing it the other way, but I didn't. Now the next thing I want to do is the equation solving. So Theo, maybe stay and watch this bit as well, please, hopefully, because this is one where you have to be a little bit careful. So we've got 4 sine of a half x minus 30 degrees is equal to 2 root 2, and we're asked to find the exact solutions in this region here. The first thing to do is to deal with the vertical stretch, because that doesn't really make life too much harder at all. So we'll divide through by 4, and we get sine of this is equal to root 2 on 2, which is equal to 1 over root 2. So that's telling me that this has got something to do with a 45-degree angle, because that's where I get 1 over root 2. So a couple of ways to think about this. I think it's worth at this point drawing a graph of your basic sine curve, right? Because we've dealt with the vertical thing here. And if you look at your sine curve when it's going from 0 to 360, we can see that there are going to be 2 solutions here, right? The first solution is going to be at 45 degrees, and the second solution is going to be going in this way. So it's going to be at 135 degrees. So when you're working at kind of AS level, it's usually easiest just to think about this thing in here as a blob, right? So think about what are the solutions here, and then to undo the half x minus 30. Just get rid of that mess from the last question. So sine inverse of 1 on root 2 is equal to 45 degrees. So what we're looking for is a half x minus 30 degrees is equal to 45 degrees. We always have to be careful with our endpoints and make sure that we're getting answers that are in our range, especially when we've done some funny transformations. But in here it works just fine. We get a half of x is equal to 75, and then x is equal to 150. So that's my first solution, but don't forget we've got a second one to get, which lots of students will forget to find. And that second one in my basic sine graph is this one at 135. So we've got a half of x minus 30 degrees is equal to 135. Is that right? Just checking if it's a half of x minus, I think I've done something wrong, haven't I? Oh, yep, that's right. Half of x is equal to 165, and so we get x. That's right, x is equal to 330. Okay, so those are your two solutions in there, and you can go and check that they both work fine. And remember, you're asked to give exact solutions. This is done in degrees, so you need to do it in degrees, although they were pretty lenient here. If you accidentally did it in radians, you were fine. Most people usually do things accidentally in degrees, not in radians, so I doubt that anyone much made that mistake, but there you go. Okay, I've got a couple more questions to do tonight. I've got one for Wentz and then 2 A-level ones, so I will be back with some more videos shortly.